Remember the last time that we were talking about how the holes on our variable is like. This is an example of a particular variable now. Now these holes are these all made by horizontal. Am I right? These are made by vertical. So now all these holes horizontally are connected at the back. That is how we have this line at the back. So which means all these rows horizontally they are connected at the back. Horizontally they are connected at the back. But vertically there is no connection. Hope you get my point now. And that is the same type sketch here. Which means these holes horizontally they are connected, as you can see. But vertically is not connected. Space to really take to the body. So left to me with my own experience, I can already tell you that it won't take more than the space, as I said. So it depends on how good you are. How good you are. Because the thing I said also when we're making use of our breadboard also. So it depends on how good you are. Now the people that have arranged this have done a very good job. So they're able to manage space. They don't even need to manage space on breadboard. At least with them out doing this with their knowledge. So they've been able to manage it. So such people should be able to also manage space on breadboard. So out of our project is our IC shape. Remember, just like our breadboard, we need to pick a line forward, positive and negative. You do the same thing here also. So, but before you pick, you must pick your spacing. So if I'm going to pick my spacing now, let me pick. No, it's a 4x4 pin. Let me pick. If I pick 1, 2, 3, 4, I think that's okay. If I insert my IC on, let me pick one. If I insert it on variable board, okay, it's going to take 4 holes. So 2 holes is going to be at the middle. It's going to take 4 holes. So let me. So and the holes that the legs is going to enter, just shade it. Meaning of my shading means that I've soldered that leg. Shade again now. So if I'm shading, it means I've soldered it. So shading. It's getting interesting now. So let's assume that this particular line here is our positive, and then this last one here too also is our negative. So let's assume that. Now, this is how our IC is to look like. And once we have this knot this way and this position this way, that means that this particular leg is what? 1. Very good. 1, 2, 3, 4, then 5, 6, 7, 8. Shape. Yeah, very good. Now, this is another interesting part I want every one of us to let's look together. Remember from the beginning I said all horizontal lines are connected together. Abi? So that means if I solder pin 1 and pin 8 on this same line, what has happened to both pins? Guess what? So that means I must disconnect those two. So those two pins now. Pin 1 and pin 8 are on the same line. Pin 2 and pin 7 are on the same line. Pin 3 and pin 6 are on the same line. Pin 4 and pin 5 are on the same line. So what I need to do at this stage now is to what? Disconnect both pins so that they can stand alone. So what will I do? I just get a blade or what you call a knife. There is a particular short knife that we use in digital electronics. But if you have a gun, get use of a blade. If you not use a blade, so and then you cut the track in between. So I use my X as a sign that I've got the track in between. Well, you can use some people even use to use their soda iron. Your soda iron is hot enough. If you place it on that track, oh my god, cut it. So I cut it. So mean like cutting is that means that from this hole here, or let me say from this hole here to this hole here is what? Pin 1. From this hole here to this hole here is what? Pin 2, pin 3, pin 4. This is into now pin 5, pin 6, pin 7, pin 8. And these are positive, these are negative. Now I can start putting in my other components. Let's start. Pin 8. Shape will make sense, but will make sense. So I think that's all. So we're done. So with this now, if I now solder another cable here, it's my negative, and another cable here is my positive, and then I connect it to battery, the circuit starts working. So, but this, let me ship in this, which I didn't say since morning. Whenever we are making use of an IC, and then we want to do a permanent soldering, be it you are using a very board or PCB, you won't solder the IC directly. You make use of what we call IC socket. So IC socket. So which means if this is an 8-pin IC, you get an 8-pin IC socket. If you are using a 14-pin IC, you get 14-pin IC socket. 16-pin IC, 16-pin IC socket. We have IC socket for every IC that we have. You get my point now. So instead of you soldering the IC directly, solder the IC socket. So after you are done with everything, you now place your IC inside the socket. Now, what's the essence of this? The essence of this is that maybe probably you did a mistake while during your arrangement, and then you connected the to power, and then it fried the IC. Instead of now soldering that IC again, you just remove it from the socket and then put in another one. That's one reason. Another reason is that let's say maybe you are working with a programmable IC. You've programmed a particular thing on that particular IC. You now want to change, you want to edit it, you remove it, you program, you put in that. That's another reason. Another reason again is that probably you have an error whereby or maybe you've done that circuit, it's something that you have produced and then you've installed for a particular customer, and then things get spoiled over time, and then after a while, the same way we used to have our inverters, I will come back to our workshop for repair and that. So after a while, you now discover that it's that IC that's problem. All you just need to do is what? Remove the IC, put in another one. So but if you didn't use socket, you don't have to go to stress of desoldering. Imagine what you are going to face to desolder something. You are going to do it successfully, but you will still face stress. So you get.